Hi viewers, in this video we are going to discuss about instruction set for 8051 microcontroller. Let us see what is instruction set. An instruction set is an order or command given to a processor by a computer program. All commands are known as instruction set and set of instruction is known as program. Let us see what is instruction format. That the first part of instruction is describes what should be done, and while other part explains how to do it. The later part can be a data, where data in the sense it is in the form of binary number or the address at which the data is stored, depending upon the number of bytes required to represent one instructions completely. Next, let us see types of instructions. There are three types of instructions are there. 1 byte instruction or single byte instruction, 2 byte instruction or double byte instruction, 3 byte instruction or triple byte instruction. In this instruction, the first byte will be a instruction code. Second byte will be a 8 LSBs of 16-bit number. Third byte will be 8 MSBs of 16-bit number. So obviously, always the first byte will be of opcode and second byte will be 8 LSBs of data or address, 16-bit data or address, and third byte will be of 8-bit MSB of 16-bit data or address. Let us see one by one. The first type is 1 byte or single byte instructions. In this case, if the operand is not given in the instruction or there is no digits present with instructions, the instructions can be completely represented in 1 byte instructions, which means that in the mnemonics, it consists of only opcode. The opcode consists of 8-bit, right? For example, end doesn't have any operand. Next, 2 byte instruction or double byte instruction. In this case, if the 8-bit number is given as operand in the instructions, the instruction can be completed, represented in 2 bytes. In this case, there are two halves of the instruction format. First of is opcode, second of is 8-bit data or IO port. For example, CPL A, that is complement accumulator. In this case, complement is an opcode and A is an accumulator which consists of 8-bit data. And next, 3 or triple byte instructions. If 16-bit number is given as an operand in the instructions, then such instructions can be completely represented in 3 bytes. 16-bit numbers specified may be data or address. These types of instructions will be classified in 5 types of instruction set. There are data transfer instructions, arithmetic instructions, logical instructions, branch instructions, and Boolean variable instructions. First, let us see what is data transfer instructions. These instructions are used to transfer a data from source operand to destination operand. All the store, move, load, exchange, input, and output instructions belongs to this group. So such simple example is given for data transfer instructions. The first one is move A, Rn. In this case, move the data from the register to accumulator. Rn, n varies from 0 to 7. Totally 8 general purpose registers are there. So it indicates R0, R1, R2 up to Rn. Sorry, R7. So whatever the data there in the register R is moved to the accumulator. The second example, move X A comma at DPTR. In this case, move the data from external RAM to accumulator. And next, move A comma direct. Move the data from internal RAM address to the accumulator. And next, move A comma at array. In this case, moves the data from the register whose address is in the RI register into the accumulator. And next, move A comma data. Move the immediate data to the accumulator. The next instruction is arithmetic instructions. These instructions are used to perform various mathematical operations like addition, subtraction, multiplication, and division. So let us see the examples. First example, add A comma R1, which means that add the content of register 1 to accumulator. The result will be stored in accumulator. Next, add C A comma hash 2. We are adding 2 to the accumulator with carry. A, D, D, C. C represents that carry. So it adds 2 to the accumulator with carry. Next, sub A comma or 2. It subtract the content of register 2 from the accumulator and the result is stored in the accumulator. Sub B, A comma or 2. Subtract the content of the register 2 from accumulator with borrow and the result is stored into the accumulator. Next, INCA, which means that increment accumulator. And next, DECA, which means that decrement accumulator. Next, mul A comma B. Mul A comma B, multiplying the content B with A and result is stored in A which contains 8 bit and B which contains 8 bits because the multiplications will produce 16 bit result. If an accumulator contains 8 bit and B contain 8 bit in the sense, the result will be 16 bit. And next div A comma B, it's dividing the data A by B. And next increment data pointer INC DPTR. Next instruction is DAA, which means the decimal adjust accumulator. These are the few examples for arithmetic instructions. Next, logical instructions. The logical instructions are the instructions which are used for performing some operations like AND, OR, NOT, XOR, etc. on the operands. Let us see the example for logical instructions. The first one is ANL, A comma RN, which means that AND logic and register to the accumulator, that is Rn with A. We are performing AND operation on Rn and A. And next OR logic A comma Rn. We are performing logical OR operation on the register Rn with accumulator and the result is stored in the accumulator itself. Next XOR, which means that logical XOR with A comma Rn. So the content of Rn and the content of A will be applied with the logical exclusive OR operation and the result will be stored in the accumulator. And next CLR-A, which means that clear accumulator, and next CPL-A, which means that complement accumulator. These are the few examples for logical instructions. And next instruction is branch instruction. These instructions are used for both branching as well as looping. These instructions include conditional and unconditional jump or looping instructions. Let us see first branch instructions, which are for conditional instructions. And first one is JC. JC means jump if carry equal to 1. And next JNC, jump if carry is equal to 0. And next JB, jump if bit equal to 1. JNB in the sense, jump if bit equal to 0. Next JBC, jump if bit equal to 1 and clear the bit. Next JZ, jump if A equal to 0. And next J and Z, jump if A not equal to 0. Next D, J and Z, decrement and jump if not equal to 0. And next unconditional jump. There are two unconditional jumps are there. One is short jump and another one is long jump. Short jump in the sense the jump which is applied within the same memory location. Suppose the jump will be applied with the next memory location or other part of memory location in the sense we are going to apply long jump. And next Boolean variable instructions. This first one is CLR-C, which means that clear carry flag. Next CLR bit, which means that clear only the specified bit. Next set C, which means that set carry bit. Next set B bit, set direct bit. With bit position is given in this example, that bit position only going to set. And next CPL or I, which means that complement the register. The I varies from 0 to 7. And next A and L C comma bit. We are applying AND logic with bit position and C. So similarly, R L C comma bit also. The next move C comma bit, which also applying moving the bit data from the given bit to C. Thank you all for watching this lecture series. Thank you.